Hi, my name is Taya Spellmeyer, and my summer research focused on analyzing different sterilization techniques for soy-based fibers embedded with extracellular vesicles. These fibers are the start of a more affordable, sustainable, and effective wound dressing. First, a little bit of background. The fibers were created in a process called electrospinning. In this process, a liquid polymer solution is charged, pulled out of the tip of a needle down an electric field and onto a collector. As the polymer chain is traveling down the electric field, the charge repulsion within the chain causes it to whip around and the liquid solvent to evaporate, leaving only the solid fiber behind. The polymer solution used in these fibers was made of soy protein isolate and polyethylene oxide. Soy is cost-effective, biodegradable, and provides amino acids that cells can uptake for metabolism. PEO is a synthetic polymer that is also biodegradable and electrospins well, so it enables the actual fiber formation of this mixed polymer solution. My lab is collaborating with a company called NewAce that is developing these fibers for wound healing. NewAce currently has a product called a Megaskin that is a soy-based film that is in the process of receiving FDA approval. While companies like NewAce have been developing these fibers, none have considered advancing the therapeutic potential with extracellular vesicles, or EVs. EVs are cellular packages that cells use to communicate with one another. They contain signaling molecules on their surfaces and inside, and this includes growth factors that can stimulate faster healing. However, in order to preserve the integrity of the EVs when they are put in the polymer solution, my lab had to change the traditional solvent that companies used to water, but this change also increased the risk of contamination in the films. So, the objective of my research was to analyze 3 sterilization methods for these electrospun films using water as a solvent so that they could eventually be loaded with EVs. So the first method that was analyzed was the use of heat to sterilize the liquid polymer solution prior to electrospinning. The next method was the addition of antibiotics, so penicillin and streptomycin, in the solvent. And the last method was the use of UV light to sterilize the soy and PEO powders prior to their mixing in the polymer solution. The films were evaluated in 4 different ways. First, the fiber morphology was analyzed using a scanning electron microscope. Then, a contamination test was performed where the films were put in transwells with media and monitored for a week for any bacterial or fungal growth. Then, the metabolic impact of the films on C2C12 cells was analyzed 2 and 4 days after the films had been introduced to the cell groups. The assay used for this was an Almar Blue assay. The final evaluation was an EV uptake experiment with the goal to qualitatively determine if EVs could be uptaken after being released from the cells. So EVs were isolated from C2C12 cells in culture and labeled with a fluorescent dye called DID. They were then electrospun into the fibers, and the fibers were put with cells and given a 24-hour uptake period. The cells were then fixed and stained and imaged to see if the EVs were uptaken. So the results. So SEM images only showed successful fiber formation in the antibiotic and UV-treated groups. The autoclave-treated group did not have fiber formation, so this method was not continued to be analyzed in the next experiments. For the contamination test results, the addition of the films showed little to no increase in contamination risk relative to the negative control group that had no films. However, while statistically significant, it should be noted that the sample size was small and future experiments should be conducted to confirm this finding. For the metabolic experiment, overall, the films did increase the metabolic activity of the C2C12 cells. A megaskin was used as a positive control in this group, and it should be noted that the UV-treated group seemed to decrease the metabolic activity on day 4, but there was one well that decreased in metabolic activity while the others increased, so there could have been a confounding variable in this well, maybe the media was changed harsher. For the EV uptake experiment, both the UV and antibiotics showed good qualitatively showed that there was EV uptake after they were released from the films. Different cell types had to be used just due to cell availability in the lab at the time of the experiments. C2C12 cells were used for the UV group, and MRC5 cells were used for the antibiotic group. This research is significant because it demonstrates 2 successful sterilization methods for soy-based fibers loaded with EVs. This is an important step in advancing the therapeutic potential of these wound dressings. Thank you.